Hello, good morning. Excellent to see all of you here. My name is Oleg Šelajev, and we're going to talk today about GraalVM. I hope you can hear me well. Excellent. So I work as a developer advocate for Oracle Labs, which is a research and development department institution within Oracle. And as a research institution, they specialize in doing actual science, right? Pushing the boundaries of what is known about computer science and about software engineering, and they publish academic papers and everything. They do actual research, and then the whole purpose of being a research and development department is to, when this knowledge is accumulated, to convert that into products for the industry, right? Hopefully for the greater good of the parent company, but if we just, are able to make lives of people better and make software engineering or software development more pleasant or easier, that's great. So if you have any questions, if you want to find me somewhere online, I go by @Šelajev, and you can tweet at me, I don't know, DM me on GitHub or something, and I'll do my best to respond to all inquiries. Before we start talking about the actual technology, please do not make any foregoing business decisions based on the contents of this presentation. That is very important. I was told so. But let's talk about GraalVM. In one sentence, GraalVM is a high-performance, embeddable, polyglot virtual machine capable of running programs in different languages. So currently we support a bunch of those. Obviously, Java and JVM languages, but also we have integrations with JavaScript, Python, R, Ruby, and some native languages as well. So it's a runtime, and it promises to be fast, and it promises to be able to run programs in a mix. So you will be able to choose which languages to use for parts of your application. So if you want to choose something else for a specific component, you can use that, and you don't have to pay the penalty of serializing data between the parts and sending back and forth. So why would you be interested in GraalVM as mostly Java developers? Who writes Java every day, mostly? Who writes like mostly other JVM languages? Scala, Kotlin, Groovy, Clojure. Excellent. Not so many. JavaScript? Excellent. So if you are a Java developer or you work mostly on the JVM, so GraalVM will offer you just a faster runtime environment, and this is clear and most obvious benefit. You can run your programs faster, whether they're written in Java or any other JVM language. There is a special mode within the GraalVM project, how you can run your programs, and then you can make your Java programs start up instantly in just a matter of a couple milliseconds and have a really low footprint. It's a special mode, so we'll talk a bit about that later. But if you are looking for ways to reduce the startup of your application, for example, if you work with microservices in a cloud environment or function as a service environment where you don't want to pay for the overhead of the startup of the full JVM, maybe GraalVM can offer you a solution. And third, maybe not the most straightforward benefit, it's an embeddable VM, so you can put it into your Java applications or your native applications and, for example, enrich that with capability of running snippets of code in different languages. So if you want to make your users be able to customize something using Python, you can build GraalVM into your application and have that capability. And we'll talk a little bit about that, and we'll see demos about that in some time. There was something wrong with the timer here, so that got me confused. If you just remember one slide or one thing node.js application. You can run it on GraalVM and others, including native things. And so GraalVM sits in the middle there, and what it does, it transforms interpreters for those languages into compilers at runtime. So it acts as a just-in-time compiler, and it produces really efficient machine code for programs in all those languages. And then it can execute that in different contexts. So it can run on the JVM in the context of the OpenJDK builds. So that would be your normal known JVM with the compiler replaced that is enriched to be able to execute all those things. It can run in the context of a normal node application. So it will start the normal node process. It will register the signal handlers that node applications do. So it will run as a normal, proper node application, but will also have the same capabilities. And it can be built in different applications. So as an embeddable JVM, we've built into the Oracle database, of course. And it allows you to execute stored procedures and user-defined functions written not in PL SQL as usually, but in JavaScript. There are experimental builds available for that, so you can try that. I personally hope that at some point of time it will make it into the actual database, I don't know, roadmap, release candidates, and somewhere. I'm not really well versed in writing PL SQL. I find JavaScript easier. The same integration is available in MySQL as a plugin, and you can do JavaScript and Python there. And also, there is a standalone mode where GraalVM compiles your application, your Java bytecodes, into a standalone image, and it does so ahead of time. So the result is a small executable that will start up fast, and it will not depend on the JVM. So you can put it into an empty Docker container or on just any normal machine and just run your program normally, but without the actual dependency on the JVM. So it's a special mode. There are a couple of things that we should talk about that you should know about that. But architecture, from the point of architecture, it works a little bit like this. So at the bottom, we will have a platform where we would like to run our things. And normally that would be a JVM, right? So since we are Java developers here, we are most familiar with the JVM. So it will provide all the services that a runtime should provide to us. A garbage collection, thread scheduling, code caches, everything that a runtime should give us so we are able to execute programs in managed languages. Now on the JVM, into the JVM, you can plug a third-party compiler using JVM CI. JVM CI is a Java virtual machine compiler interface, and it was added to the JVM to OpenJDK in Java 9 through a normal JEP. So it's a functionality that is there. We backported that back to Java 8, and we are using that on Java 8. But through that interface, you can plug in the third-party compiler, and the compiler will be used as a top-tier compilation process for your code. So it will feed the bytecodes to the compiler and get the machine code back, right? So if you want to write a compiler for the JVM, you can do that using the JVM CI interface. And we did that. So now we have the Graal compiler. And through those two layers, we can execute Java and all JVM languages naturally, right? So nothing else is necessary because the JVM will find and load the classes. It will execute. We'll just feed it to the compiler, and then we'll do our magic, and you get a really efficient machine code back. So for other languages, you need more things. So there are a bunch of other components. So Truffle Framework is a framework for implementing managed languages, and it is kind of loosely, but also very directly integrated with Graal, so they're aware of each other. But it's an API that allows you to implement an interpreter for the abstract syntax tree of your language, right? So you create the tree, you parse the tree, and you evaluate that at runtime just going through nodes back and forth. And typically, that would be a very slow approach to execute programs in different languages or in any language. But with the Graal compiler, we are able to optimize those trees really, really well. And on top of the Truffle framework, with those APIs, we've built interpreters for Ruby, R, JavaScript, and Python to run those languages. And then we also built the interpreter for the LLVM bitcode. So anything that compiles to LLVM can be run on GraalVM. And there are different performance characteristics of different languages, but we would like to make GraalVM the fastest runtime for each of those. So at some point of time, it should be the fastest JavaScript runtime, it should be the fastest Python runtime, it should be the fastest R and Ruby, and the fastest way to execute Java. And we are not 100% there for different languages. JavaScript is, for example, V8 is really, really fast, and it's really hard to beat the performance of native code. But all over the board, there are use cases and workloads where GraalVM is currently better than the state-of-the-art runtimes for all of those, except maybe native. I didn't check native, but so we can be faster than normal JVM for Java, faster Scala. Ruby and R are not known to be really fast, so their GraalVM gets ridiculous performance boost, and others are as well. So this is what the components are. Later today, I'll have a session about Graal compiler and specific optimizations, which it does, so we can learn a little bit more about that. But today and now, I want just to give you an introduction of what's possible and what to expect from GraalVM and how to get started and make use of that and what to think about the project. So besides the high performance, one thing that is very interesting, especially to the Java community, is this low memory overhead fast startup mode. We call it GraalVM native images, and this is the AOT compilation, ahead of time compilation to the machine code. So your program will still work with the garbage collection, so it will work normally. It will also provide you with security guarantees, and the result binary is embeddable in applications. So when you compile your Java app to native images, then you don't run Java dynamically on the JVM, but you just get a one binary file that you can execute. It can be a shared library as well, but most normally you will just get the standalone executable. During the native image generation, there is quite a bit of things happening, but essentially we take all the bytecodes that your application will ever execute, and then we analyze that, we figure out what calls what, we build the dependency graph going through your application dependencies that you use in your project, through the JDK classes which you are using in your project, and then we compile all that to the executable. We also include the image heap, which is the pre-initialized version of the heap of your application. So essentially, what it gives you, the native image gives you, it gives you two different phases where you can run your application up until a certain point of time. So currently we execute, by default, we execute static initializers of the classes at the image build time. So when we build the thing, and then all that initialized memory, all those data structures, all that config is written to the image heap, and then it's available at runtime from the get-go. So the performance, the peak performance of the native image will probably be a little bit lower than the warmed up, just-in-time compiled Java code, but the startup can be very interesting. So that is a very thing to know about the native image, that there are two different phases of what it does. That's important to remember. If you want to experiment with Graal, if you want to get and try it or evaluate it, it's an open source project. The source code is available on GitHub. The development is going on GitHub. So you can go and there are a bunch of projects, but the main one is Oracle/Graal, which includes different components. The language implementations are mostly available in different repositories, but they're also open sourced and available right there. The licensing for that is typically what makes sense for the languages which you actually use. So for Java components and Java related components, that would be GPL2 plus class exception, just like OpenJDK. For Node components, that will be Node license. For Ruby licenses. So we try to be a good citizen of the open source community. It's all written in Java, which is a big plus, because if you're a Java developer, your default toolchain will work on that code. So you can just clone it, open it into your favorite IDE, and click through methods and classes to understand what it's doing. So if you're interested in a lower level development, then you can check it out. You don't need to know about pointers and which is a dereferencing operator or how C memory allocation works. You can use your normal toolchain, normal programming language. If you don't want to do all that and you just want to use it, the best way is to just download and use the pre-built binaries that the GraalVM team provides. Currently, there are two flavors that you can get. One is the community edition, built out of the open source components, available on GitHub. You can build that yourself, but you can also just download the release from GitHub releases as well. And there is an enterprise edition, which comes with the differently tuned compiler. So there are a little bit different optimizations, and it provides you with better performance. So your programs will be running faster. There are also a couple of scalability and security features. We'll talk about this a little bit later at the relevant demos. But mostly, Enterprise Edition differentiates itself on performance. So Community Edition is equally capable. It can run the same programs. It can run the same languages. It can run and create the same native images if you're interested. It's embeddable the same way. The API is the same, but you can run whatever you would like to run on it. But if you want additional performance, if you consciously choose that, then you can consider switching to the Enterprise Edition.